homework problems that you had to make sure that you understand what you're doing with these logarithms. So yesterday we talked about exponential functions and logarithms being related in terms of a logarithm is equal to the exponential function. A is your answer, B is your base, X is your exponent. That's an exponential form. In logarithmic form, that would look like log base of B of your answer equals your exponent, and that's log form. And quite often, if you need to eliminate a logarithm, you'll rewrite your answer in your problem in exponential form and vice versa there. So if you look at something like number 3 from the homework, I'm just going to do some random problems here. Log base 2 of 32. If you set that equal to something, you can rewrite this as 2 to the x equals 32. And then 32 you can write as 2 to the 5th. So that logarithm, log base 2 of 32, this is equal to 5. If you look at something like number 5, log base 5 of the cube root of 25. That equals something. I'm going to call that x. Write it in exponential form. The base is 5. X is the exponent equals the answer part, which is cube root of 25. We need to be able to write these with the same base. So 25 is 5 squared, and the cube root is the 1/3 power. So 5 to the x equals 5 to the 2/3. Bases are the same, so the exponents are equal. So log base 5 of cube root of 25 is equal to 2/3. If you skip down to something like number 9, there we go. Right, so something like number 9, we have log of 100,000. And there's no exponent written there, no base written there. Remember, that's a common log, so that would be log, the base would be 10. 100,000 equals something. So this you could rewrite as 10 to the x equals 100,000. And then you have to write 100,000 as 10 to an exponent. So that's going to be what, to the 4th? So x would be 5. X would be 4. So trying to get this thing to erase. There we go. And then let's look at some natural logs. So ln e to the 3rd, that's number 13. Set that equal to something. Remember, natural log, ln is log base e, and then it's of e cubed. And this we can write in exponential form. The base is e, the exponent is x, equals this inside part, the answer part, which is e cubed. So it's equal to 3. There's another way to solve that problem as well. We just haven't gotten there yet. Alright, and let's try number 17. So 17, we had ln of the 4th root of e. Again, set it equal to something. We can rewrite ln as log base e. You don't have to do that step there. That's just to sort of emphasize that that's what the base is. That's where that extra e comes from. And then exponential form, base is e, x is the exponent, equals e to the 1/4 power, which is the 4th root. So this is equal to 1/4. So that's the idea in that beginning part. The next part, 19, 21, 23, they just want you to simplify this. And we had some properties for logs that you could simplify this a little more easily. And then we also proved why it simplified to what it did. So we did one like this yesterday. It was 12, I think to the log base 12 of pi, something like that. So when the base for the exponential function and base for the logarithm are the same, it's just equal to the thing that you're taking the log of, which is 3. If you don't see it, you can set it equal to some variable. we would write this, it's an exponential form, write it in log form. So log, the base is 7 of m equals, logarithms equal exponents. So it would equal the exponent of log base 7 of 3. And since these bases are the same, the things that you're taking the logs of are equal. So that's sort of the long way to go through and do that, but that's why it works. So if you look at 21, you have a base of 10, you have a log that has a base of 10, so this is just going to equal 0.5. It doesn't want to write on that. So for 21, that's just going to equal that 0.5. And same thing for 23, it's e to the ln of 6. ln has a base of 3, so that's really e to the log base e of 6 is just going to equal the 6 there. All right, let me slide some of this stuff around here. 25 through 31, you were just typing those in your calculator. For 27 and for 31, you're going to get an undefined value because you can't take the log or the natural log of a negative value. And then 37 through 40, these you were just matching the graphs with the transformations there. And you could type those in your calculator if you like. Yeah, I'm not going to ask you much in terms of translations there. Okay, so the last thing that you had then was in the notes, we never did the application problem. You have a few application problems in tonight's assignment. So if you look in your notes there for the last part of 3.3, measuring sound decibels there, you have a couple of problems that are similar to this. So they give us this table of values, and this was all different sound levels from something as quiet as a soft whisper to a jet taking off. And they give us this equation. It's in the blue box here, and it's hard to read. So I retyped it down here for you. And the value they give you for I sub 0, or your sort of the quietest sound that you can hear, is this 10 to the negative 12, and then, I don't know, W over M squared, which is, I think, watts per something or other there. I don't know what the unit stands for. So anyway, if you go through and you fill this in, B is the number of decibels. And we're going to go through and figure out what is the, how loud is the train inside the subway tunnel. Train inside the subway tunnel is right there, 10 to the negative 2. That's our value for I, the intensity. So 10 log, this would be 10 to the negative 2 divided by that initial intensity, or, like I said, the sort of quietest sound that you could possibly hear. Both of these would be measured in this same unit here, which ends up canceling out. So the number of decibels then is going to be 10. This logarithm doesn't have a base written, so it's understood to be base 10. And you can put this in your calculator. If I bring this 10 to the negative 12 up top, I'm going to have 10 to the negative 2 times 10 to the 12. Multiplying the same base, you would add the exponents, so it would be 10 to the 10th. And then this thing you could simplify. This log base 10 of 10, put it in your calculator if you like, but when those bases are the same, it's just equal to this exponent. So I have this 10 out in the front times this 10 would give me 100. And this would be decibels. So they give you a few word problems like that, and they give you the information. You don't have to come up with the equation. They give you the formula. But this formula, I think they assume that you did the example in the notes so that you have that formula somewhere. So you might have to refer back to that. Okay, so you're going through, you're doing some even problems of the same set. The only thing that will be different is the last few problems are some word problems there. And the assignment is on the front board and on the back board.